Hello, this is my summary of how I solved for the Machine Learning Foundations for Product Managers course wrap-up project. And in this, I will walk through my thought process as to how I came to the final solution or approach for the problem that was actually provided. So in the course wrap-up section, the problem statement is as follows. In this project, we'll build a model to predict the electrical energy output of a combined cycle power plant, which is a combination of gas turbines, steam turbines, and a heat recovery system, steam generators to generate power. We have a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we'll use in our model. The features in the data consist of hourly average ambient variables, such as temperature and range indicated, ambient pressure, relative humidity, exhaust vacuum, as well as the net hourly electrical energy output, which is the target variable that we're trying to predict, with the range is indicated. Now, I also took the liberty of copying the guidelines or the things that to look for essentially in the solution. I won't drain all of this information because obviously it is actually present in the course. At the very end. The only thing that I'll add here is that I did use Excel, because that was the easiest thing for me to use, and the fastest way to actually arrive at the solution. In order to actually get the the outputs that I'm looking for the outcome metric. A few more things around the algorithms and models that I used. I decided to use multiple linear regression because we don't have a large enough data set for use of lasso or ridge regression. Based on the information in the course, also I decided to go with the 80-20 split between my training and my test data. Model A will include the features of temperature, exhaust vacuum, ambient pressure, and relative humidity. Model B will include temperature, exhaust vacuum, and relative humidity. So within Excel, I found that essentially this was the output within Excel for those four features. And as you can see, the ambient pressure, one thing that's interesting is the ambient pressure here has the lowest correlation based upon the coefficient here. And so that is how I arrived at removing this variable, removing this feature, if you will, from the model in order to actually come up with another model because it's got the lowest coefficient. And in addition, you'll notice that the R squared here is about 0.929, let's say 7, as well as the metrics here that are also included in the course. The root mean square error, the mean absolute percentage error, and the mean absolute error are calculated here. And as you'll see, when I compare these values to model B, which only has 3 of the features to predict the target, the R squared here is, there's a slight variation, 0.929, let's say 4, as well as the metrics that I calculated for the previous one. So there's a very slight, small difference between model A and model B. Model A seems to be a better predictor, more accurate based upon some of these metrics. So what I did was I actually decided to run the same thing on the testing data as well. Here we had 7,655 observations, and then within testing data, right, 20% of the data, 1,913 observations. And as you can see, the R squared here is 0.9248, or let's say 9, along with the metrics here. And then for model B, it's 0.9245, again, with the metrics calculated here. And again, as you can see, the variations are very tiny. But when I do a difference between the two, it looks like when I compare them side by side, both the training model output as well as the testing model output, it looks like model A is a better predictor because of the some of the metrics that we calculated here, as well as the R squared values that we showed in the previous slides, that I showed in the previous slides. So because of that, I decided that model A is a better predictor of the target variable. And so I would actually recommend model A. However, because the differences are so tiny or so small, in the real world, I would also want to consider additional features that may give us a better, more apparent outcome, if you will, of the results. So in other words, we may be able to see, a clear winner as opposed to what we have here, because here the differences again are very, very minuscule. So in the real world, I would actually want to maybe ask for additional features, additional information that may cause us to actually have a clear winner. But nonetheless, I would still go with Model A because the metrics are slightly better, than Model B, which includes all the features that predict the target variable. Anyway, that's it. Thank you very much for reviewing my project. Have a nice day.